to make sure everybody's on the same page here. Skylar's presentation will actually be at 5 o'clock in the ballroom over there. There was kind of a last-minute scheduling change here. My name is Guy Broome. I'm with VCU Technology Services. What I'm going to actually stand up here and talk to you about today, you know, there's kind of some information floating around. Oh, it's key escrow and Active Directory and Linux encryption. The real subject here is going to be that we need to be not treating open source operating systems as second-class citizens in the enterprise. And not only how can we avoid treating them as second-class citizens in the enterprise, but if we do decide to implement them and actually support them fully, how can we go about that in a way that is going to be compliant with our policies and actually be generally well supported within our infrastructure. So to give you a little bit of background here, I'm going to move around here. Is that volume level okay with everybody? All right. So to give you a little bit of background here, VCU, as many of you probably already know, is, for all intents and purposes, a state agency. We operate as a four-year public university. You know, we have a lot of autonomy from the Commonwealth of Virginia, but we are, in effect, still a state agency. And that comes with its own set of challenges and struggles and difficulties that are fairly unique to our organization that set us apart from both private sector and public sector businesses that are not government agencies. One of the tricks that we have to do is we often have to implement some very, very complex, intricate, and multifaceted policies on very, very minimal budgets here. You know, there's always that almighty dollar that has to be catered to and kept moving there. So let's talk a little bit about what we actually mean here with this concept about adding the E. First of all, what E are we talking about? What E? The E, simply put, is enterprise management. We're talking about bringing oversight, accountability, reliability, all to enterprise-grade software, right, in a free and open source environment. So the E, simply put, is enterprise management. Now, when we talk about bringing enterprise management to free and open source software, there are always some misconceptions that like to float around there that we need to address. Many of you are probably familiar with, you know, the archetype. I'm actually going to move my microphone here so it's not dangling down beside me. Many of you are probably familiar with the archetype of the free and open source software aficionado as kind of a tinfoil hat-wearing individual. Pictures of Stallman and Torvalds on the nightstand. I get that misconception quite a bit in my day-to-day work here. Somebody hears you talking about free and open source software. You know what? We're just going to leave it. Somebody hears you talk about free and open source software, and they immediately develop a certain stereotype of not only the technician who's mentioning that, but also of the software we're talking about. You know, Linux in particular kind of grew out of sort of a basement computing movement, and in modern IT, even though it powers a lot of the world's most powerful servers, websites, you know, Fortune 500 companies, there's still kind of this IT perception. Linux is still the realm of you know, it's still the realm of hackers, right? And to a large extent it is. But it doesn't necessarily have to be that way. We can actually bring free and open source systems, not just servers, mind you, but clients as well, and actually integrate them in with the enterprise. Now, first question is, why do we care? We're not talking about servers here necessarily, remember. We're talking about clients. Well, I don't know about most of your organizations. How many of you here are in private or public sector, outside businesses, non-governmental? All right. How many of you here are government agencies? All right. In your careers at your agencies, how many of you have actually seen at some point a user with a business-issued laptop running Linux? I see one, two hands going up there, maybe three, all right? Out of this whole room of people here, we only saw a little bit of maybe 3 hands go up there. So why do we care about bringing enterprise management to such a small proportion of systems? In order to answer that, we have to ask who's using those systems. Do you think that your Linux server administrators, the people who are managing your website, the main website for your organization, your directory servers possibly, all sorts of infrastructure. Do we think that when they're done at the end of the day that they're sitting there on a Windows laptop? They may be. But a lot of times the folks who are actually running these free and open source software client systems, a lot of times the people who are running those or using those systems are actually your IT administrators, your technicians, your programmers. They're the folks holding the keys to the kingdom there. And if you have an institutional mandate to make sure that those devices are encrypted and protected, and the folks who hold the keys to the kingdom are not protected and you're exempting them, you've got a problem. What happens if your institution's webmaster running Linux on his or her laptop goes out and across the street one day, gets hit by a bus? Even if your system administrator was smart enough to have that laptop encrypted, hopefully they were, if you don't know that password, you're out of luck. You may very well end up having to rebuild a server from scratch, even if you have a good plan in place, because odds are in a complex environment, there are going to be all kinds of subtle little nuances that delegated authority and delegated technicians may not be aware of. So even though these Linux client machines and these free and open source client machines represent a very small minority of client deployments in most organizations, because they're the folks who hold the keys to the kingdom, it's important to have not just visibility, not just security, but manageability on them as well. Now, in a lot of institutions, we actually have security on these machines mandated by policy, right? Here at VCU, for example, we actually have a directive from our Board of Visitors, which is kind of the governing body of our university, that all university-owned portable devices must be encrypted. Now, we can set aside the compliance issue with that as a separate discussion for a separate time. There are always challenges along those lines, but in this case, we had to implement that. It's required. There's not a provision there. They didn't say, oh, well, if you're running Linux on your laptop, you don't have to worry about it. All. That was it. Mandated by policy. Avoiding obsolescence. I kind of touched on this a minute ago, right? If your Linux server administrators, web admins, those of your folks, of your employees, your coworkers who hold the keys to the kingdom, are using one operating system on a day-to-day basis on their individually assigned machines, and then they're using another one on servers, guess what? Odds are their knowledge is about 6 months behind. How many of you, for instance, were aware that the code, the basic code to support live kernel patching, that is kernel patching without a reboot, actually went into the mainline Linux kernel just a couple months ago? How many of you are aware of that? I see a couple hands go up, right? Now at the moment, that's on the client side. If you want that server side, for most distributions, you're still looking at party solutions. But it's going to be hitting the server side within a few months eventually, right? I mean, it's coming, it's imminent. And if you're only using the server side distributions and you're not touching the client side, your knowledge is already out of date. You need to be careful because you're vulnerable. And we might sit here and think, okay, well, we know that these portable devices need to be secured, we know they need to be managed, we need to have visibility on them. We need that E, but there's nothing out there for it. Any of you ever gone shopping for disk encryption management suite? Something like maybe Credent or any kind of advanced tools for BitLock or DDP, anything of that sort? Any of you ever had to shop for or support any tools like that? You ever gone out there and looked for tools available like that for Linux? You can encrypt the disks fine. You can set security policies on the system just fine. If you're a really savvy organization, you might even be able to do all of that through LDAP, or a good deal of it. But if you want a tool that, for example, does periodic reporting such that when that machine reboots or when somebody logs in, you get a ping back to a server that says, yeah, this disk is encrypted as of 5 minutes ago, good luck. You're going to have a really hard time finding that. Luckily, we don't have to be stopped by that. There's no reason whatsoever that we can't fix that, right? These are free and open source systems. That's the whole advantage of them. That's one of their biggest selling points, is that their architecture, everything under the hood, is right there available to you for anybody who wants to look at it. It's not a mystery. It's just a matter of going and reading the documentation, perusing the source code if necessary, finding what you need to implement, and implementing it. Now, lest you think that we're just, kind of blowing smoke here and talking purely theoretical, let's talk about what a good tool that would answer this need might actually look like. I mentioned that there are no tools available, or at least no good tools, right? A good tool for security management on free and open source systems should support centralized CSR, configuration, storage, and reporting, configuration of security parameters, storage of cryptographic keys if necessary, and periodic reporting on the status of that machine. So that if that machine is lost or stolen, we know exactly when it was encrypted, what the security configuration was, and at what time those policies were there. It also needs to support flexible deployment. When I'm dealing with anything in the Unix or Linux worlds, one of my pet peeves is when you find an absolutely wonderful tool. It's a great tool, it does everything you want it to, and then you try to take it to a different Linux distribution, it breaks and it doesn't work. I think most of us have probably been there before, right? Found some wonderful tool, it's great, it does everything you want, take it from, say it's developed for Red Hat, and you decide to go over there and take it to SUSE, and it's dead. Drives me nuts. A good tool needs to be flexible in its deployment, it needs to use standardized cross-distribution technologies that work no matter what version of Linux or what version of Solaris or what version of even the BSDs you might be running on. It needs to have staying power. You don't want to build a tool, put all the time and effort into it, and then 2 years later, nobody's around to maintain it. How many of you ever had that happen before with a piece of software? Right? Especially when you pay a lot of money for it and then the company goes out of business. That's always fun. Everybody loves that. And it needs to have community acceptance, right? Most of these server administrators, most of these Linux sysadmins, especially in particular on the those who are the diehard Unix fans who've been with it for 20, 30 years, they're going to be very resistant to putting a tool on there that they cannot themselves review the source code for. If you give somebody a tool and it's binary only, closed source, black box packaged up, they can't look at it, and you tell them they have to put it on their laptops or on their servers, they're going to look at you and laugh. Good luck, right? They need to be able to review, the open source community needs to be able to review the tool, see exactly what it does, and the advantage here, the kind of upswing for us as developers, is that we get, as kind of what we were talking about here, we get free bug fixes out of this. If we develop a tool that's open source and has community acceptance, we get free bug fixes and patches contributed by the community to our product. I don't know about y'all, but I like that price. All right, so what we're going to do here in a few minutes, we talked about the general problems of bringing enterprise management to free and open source operating systems, particularly for full volume and file-based encryption. We've discussed that. Before we go any further, we're actually going to delve into kind of a practical example here in a minute, and then we'll wind up today with a demonstration, a live demo, the dreaded live demo at that. But before I go any further, does anybody have any questions, any sort of clarifications on what I've already discussed about bringing enterprise management to free and open source systems and some of the challenges involved with that? Anybody, go ahead and throw up hands if you have any questions right now. Nope? 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 No hands? All right.
I assume you're about to show some details?
Yes. Yes. Say that again?
You said client versus server. I assume you're specifying.
Correct. Predominantly they were talking about distributions, particularly in the sense that in servers you're generally going to have them secured in data centers, obviously not always, but you may not be worried about full volume encryption on a server because it's typically already behind enough physical security. You may or may not want encrypted swap, that sort of thing. But on your client versions, on your laptops, and maybe even in some cases on desktops, those things are traveling out, going to coffee shops, and goodness only knows where. So in this case, client versus server means, does it have physical security, does it stay put, versus does it get up and roam around frequently? In this case, my particular concern is laptops and, oh, you mean a client distribution? This is developed to be cross-distribution. I specifically developed a tool that would work on, I've tested it on Fedora, OpenSUSE, I've actually done some limited testing on FreeBSD, Debian. I think I've run a test or two on CentOS for it. Part of this Part of this requirement up here was that we don't want something that's distribution specific. We don't want that. Yes? We'll come to that in just a minute here. The client-side tool, in other words, the tool that actually runs on your workstations, is pure bash script. There are a few third-party programs that pulls in, like an LDAP client, if you want to upload keys to Active Directory, but the tool itself is actually bash script. The great advantage of that is that, for one, it's very easy to modify if you need to tweak it to your own needs. Not a whole lot to mess with. The other side of that is that just about any Linux distribution you get is going to have bash on it. You don't have to worry about, oh gosh, do I have Python installed? The optional reporting server, where clients can actually store their keys, and we'll come to that in a minute, is actually written in Erlang. So let's actually look at the practical example here before we go on to the live demo. All right. The first thing we had to decide here at VCU and VCU Tech Services, this may be different in your organization. First thing we had to decide was which clients did we want to support. In the case particularly of full volume encryption, the technologies, there's a wide variety of them available for different operating systems, right? What's available for full volume and file-based encryption on the BSDs is different from what's available on Linux, is different from what's available on Mac, is different from what's available on Windows. It's all over the place. Which ones do you need to support, right? And there's a whole plethora of different clients available. So in order to decide where you need to put your development time, you have to look at where the power players are, the folks with the keys to the kingdom. Look at where they are, look at what operating systems and what full volume encryption technologies they're using. That's what you need to support in your institution, right? That's what you need to support. The next thing we have to go into is, what do we want to configure, right? Do we want to enforce encryption on certain machines, or do we want to simply collect information on machines that have already been encrypted, right? Do we want to actually require users to encrypt their machines when they run our tool? That's one thing there. Another one, if we force users to encrypt their machines in a support capacity, that means the onus of backing up that recovery material, that key material, that means the onus of it falls on us. If we allow the users to have discretion, right, and then we just serve as kind of a management portal, the user is going to be responsible for maintaining their own keys. We just keep a backup of it. If we force the user to have keys installed on their system or to encrypt their volumes, the onus falls on us to actually make sure that that material is secure. Do we want to require, for full volume or file-based encryption, do we want to require certain cipher suites? Maybe we don't want Blowfish in CBC mode being used to encrypt a volume. It's a nice fast cipher, got great performance, but we're not sure how secure it is. Maybe 256-bit AES in Galois counter mode is a little bit too much. Maybe that's overkill. Maybe it's not fast enough. You might have machines out there that don't have acceleration in their CPU for that particular algorithm, right? What precisely do you want to encrypt, and in what method do you want to encrypt it? Next decision that has to be made, do you even want a password at all? How many of you here have used Windows BitLocker before? See a couple hands going up. You're probably already familiar with the fact that in the default configuration, the keys to unlock that volume are actually stored in the Trusted Platform module, if provided that your machine has one. When you log in and you type your Windows login password, you're not actually unlocking the volume. That volume was already unlocked to boot through a password stored in the Trusted Platform module. And all that BitLocker does is that guarantees that you can't go in there and subvert the operating system's built-in file controls, right? So do we want a password at all? Do we maybe want to store keys in a TPM, right? Do we maybe want to make our users carry around a thumb drive, or maybe even use a one-time password? It is possible, by the way, to use a one-time password if you have certain mechanisms in place. You can actually use, for example, like a YubiKey to unwrap a master key and then do volume encryption based on that. It's a little bit tricky, but it can be done. Do you encrypt swap space? This is a big one. And I think one of the gentlemen in this room here we've had this discussion before in a server context. Encrypting swap space is a big deal. It can significantly improve the security of any given system because it makes it much more difficult for a remote attacker to go in there and, for example, to rip out data from a previous boot on unformatted or unclean swap space, right? But it also can potentially slow the system down in some cases. Do you want to encrypt swap space or not? Do we require TCG compliance? Quite a few institutions, I think particularly in the federal government level and with the U.S. Armed Services, for some of their sensitive systems require TCG compliance. That's a system whereby during the boot process, every executable file is validated, checksummed, and signed. It's kind of a little bit more of an open precursor to secure boot, if any of you are familiar with that. We may require TCG compliance. And for the sake of time here, I'm going to move through the rest of these fairly quickly. Do you want users to be local admins of their own machines, right? If you decide that from the top item that you want to actually enforce an encryption policy, it's okay, yeah, we want to make sure that these drives are encrypted. But you give your users local admin rights on their machines. They can go through and decrypt their machines behind you. If somebody has local admin rights on their machines, they can make any changes they want to it, right? Do you want your users to be local admins? Here's another really good one. How many of you are familiar with the recent exploits that were disclosed where you can either insert a specially crafted USB or Thunderbolt device into an external connector and yank out the contents of the system's hot RAM? Right? Do you want to deploy an intrusion detection system that maybe attempts to find if a system is being attacked or if its keys are trying to be compromised and will shut down or reboot that system for a certain amount of time to possibly clear the RAM out to help make the attacks a little bit more difficult? It's another valid thing to try and integrate into your tool. So all these concerns are swirling around you, right? And these are all things that need to be evaluated before any sort of decision is made to implement a cryptographic data management system for free and open source software. Next question, of course, and this is going to be mostly boilerplate for a lot of you, I think. Next question, of course, is what to store. As most of you probably already know, we're feeding key material. The most straightforward encryption model is you feed key material and plain text into an algorithm and it spits out ciphertext. And to get your ciphertext back out, you do the reverse. This should be pretty well standard to anybody in here, right? But that's the most simplistic model. It can get quite a bit more complicated than that. In many cases, you might have a hash password. You could have a randomly generated key wrapped with a hash password, right? That's another very valid option that's used all over the place. Might include an initialization vector that you need to store to help perturb the encryption algorithm or the hash function. Could be a single random key as a master passphrase wrapped with a bunch of different outer ones, right? So we sit there and we tend to think, okay, well, we need to store the key, right? Well, not always. Typically, yes, but not always. So for any of the architectures and systems you considered, what actually do you need to store, right? In our particular case, and the practical example that we'll move on to here in just a moment, we're mostly interested in storing the wrapped inner key. We don't care about the user's password, right? The two encryption methods that we selected both rely on an inner wrapped key or a series of inner wrapped keys protected by a user's password. We don't care about the user's password itself. We don't need that. We just need the inner key. We face similar dilemmas when asking what to report here. Again, for the sake of time, I'm going to speed through these. We may want to report up to a server at periodic intervals which volumes, which file systems, which mount points have actually been encrypted. If a user went through and encrypted their root volume but they didn't encrypt their home partition, they didn't do you a whole lot of good. Likewise, maybe they went through and encrypted their home partition but forgot to encrypt their swap, and if you're on a laptop, well, right? System inventory, that goes back to the TCG info. Do you want to actually collect metrics on the boot process, for example, checksums of the various bootloader stages or signatures, and upload those to a server to make sure that those are valid according to your enterprise's standards? Indications of tampering, lists of users who logged into the system. All of these things are potential items on which we might want to report. All right, so any questions at this point before we move on? Nope, all right. Let's keep rolling. Now, I'm going to state here for the record, VCU, we have had this, as I mentioned, we had this directive from our Board of Visitors that all portable devices needed to be encrypted. We didn't want to exempt free and open source operating systems because they're used by some of our IT administrators and technicians here, in other words, the folks with the keys to the kingdom. So we said, okay, let's not exempt them. We shopped and looked around and attempted to find a product that would do centralized configuration and management for encryption on open source systems. Couldn't find anything. We hunted for months, right? So the result was we decided, okay, we'll sit down, we'll get a developer in-house, and we'll develop a proof of concept right here at VCU for a system to manage full volume encryption and do some reporting on cryptographic storage on free and open source operating systems. And thus was born MLA. All right, let's look a little bit at the architecture of this particular product. The whole thing started out very simply, very minimal fashion, as a bash script. Nothing else, right? It's just a bash script that called other utilities on the Unix system. Not a whole lot else to it. This bash script's initial function was to collect keys from one of two sources, either encryptfs, which is a file-based encryption method, or LUX/dencrypt, depending on what you want to call it, which is a full volume encryption method. There are plenty of other encryption methods out there for Linux. You know, everybody has their favorite. Everybody wants to throw out there the various spin-offs of TrueCrypt. There are quite a few others. In this case, this is what we found was being most widely used in there. You know, we could have supported the legacy crypto loop in there, but we don't really want to encourage people to use that because it has known weaknesses, right? So the MLA architecture collects keys, the client script, collects keys from one of those two sources, right? Uses the standard open LDAP client tools, LDAP add in this case, right, to connect up to an Active Directory domain controller, just like a Windows machine running BitLocker would, and store those keys directly in Active Directory, just like a Windows machine running BitLocker would. And not only this, when we do the practical demo here in a few minutes, you'll see this. Not only does this use the same method, any of you ever been into Active Directory and pulled up a computer and done the BitLocker recovery keys tab? If you use this script, you get your Linux encryption keys for encryptfs and LUX in the exact same place. You join a machine, the Linux machine to Active Directory, it's on the domain, you can get your encryption keys right there for it, just like you would a Windows client. And your IT team can then access those providing they have the appropriate permissions within your Active Directory infrastructure. Okay, so that was great. Got that client script up and working, it worked really well, we were really happy with it, and my boss came back to me and he said, hey Guy, you know what would be really great? This is where I stopped for a second, I went, oh no, here it comes. Oh no. It would be really great if we could collect status on those and have those machines just periodically ping back to a server and say, hey, I'm still encrypted. Should be pretty straightforward, right? Should be pretty simple. About 4,000 lines of code later, all right, we ended up with the MLA server. The MLA server is written in a language called Erlang. How many of you have ever heard of Erlang, just out of curiosity? I see a fair number of hands go up. That's good. I like that. For those of you who haven't heard of Erlang, we'll dive into some of the technical details in a second, but have you ever heard of Facebook Instant Messenger? The last I checked, they actually use, for example, they use Erlang on some of the back-end products. Erlang is a distributed, fault-tolerant, concurrent programming language designed for nonstop applications. Supports things like hot code replacement. In other words, you can have the compiled program running as a web server process, recompile, and replace code without actually having to stop the program. It's kind of handy. Has built-in message passing, concurrency, and processing techniques. It's basically a great language for developing a web server, or a web application for that matter. So, we already had the Active Directory, the key escrow to Active Directory, right? Now, of course, that doesn't do any sort of status reporting, it just, here's the key, right? So if that user changes their key, or the machine goes down, or it's reprovisioned, you have no way of knowing. The MLA client connects to the MLA server over an HTTPS API. No, it is not RESTful, I wish it was, that's in my future design plans, in case anybody was gonna ask. It's not a RESTful API at this point, it uses standard CGI calls. Connect over an HTTP API to the Erlang server, to the MLA server. and can do the same thing that we can with Active Directory, which is it can upload keys to the server. It can also do periodic status reporting, right? So the machine can phone home to a server that you've configured and say, hey, I'm alive, this volume's still encrypted. And it also supports pushing configuration from your server out to a client. And this is where I usually, a lot of the free and open source OS users go, wait a minute, pushing configuration out to my client. That's the beauty of the whole thing being an open source project itself, is that you have the option of going in there and seeing exactly what it can push, how it does it, and making sure that it suits your needs. And if something in there is not a fit for your institution, you can change it. And the MLA server itself also supports a tiered management approach, just like you would expect out of any comparable tool, where you can define users in the web server, which users can recovery keys, which users can add and remove and delete machines, and so forth and so on. So it's got a nice tiered layer of privileges there. There's a bit more detail on our laying here. Since we're a little bit short on time, I think we're going to go through this. I've covered most of it already here. Right. So, by our earlier standards, MLA is a good tool. Has centralized configuration. We can push out configuration, centralized storage of our keys, and centralized reporting, all in one place. We've met that goal, right? Flexible deployment. The client-side component is pure bash. That's it. That's all you need. You got to make sure you have the open LDAP tools if you want to upload to Active Directory, but you don't even have to have those, right? Flexible deployment is going to work with just about any Linux distro out there, and I've even had a chance to test a few experimental branches of the code on some of the BSDs, right? That's handy. It has staying power. The product has been released under a 3-clause BSD license. Source code's publicly available. You guys can go out there after you leave here today and look at this if you want to. It's not some black box hiding behind a counter. Anybody who wants to make changes is welcome. I actually have a few personal friends of mine from some very large name IT companies who periodically help me out with this just to kind of ensure that it doesn't fizzle into obscurity. And it has community acceptance. It's released under an accepted, established GPL, GPL linkable, GPL compliant, GPL friendly 3-clause BSD license, right? It can be integrated with various other products as your particular organization sees fit. So, the takeaway from this, before we go into this a whole lot further here, the takeaway is, as we covered at the beginning, free and open source systems in the enterprise do not have to be second-class citizens. There are very good reasons for ensuring that they're well supported and fully compliant with policy, and it's not a pipe dream, it's not a pie in the sky, it's doable. We sat here and wrote a proof of concept product in about 4 months of casual side work by one developer that could achieve this goal of managing the encryption on it. It's very doable. So option 1, you can just ignore the issue. If you have free open source client machines in your organization, you know they're not policy client, you can just, okay, fine, whatever, let's not worry about them, walk away. Certainly an option, not a good option, but it's an option. Cost of that is very low. You just sit back and watch the world burn. Not a whole lot else to it. Benefits also very low, unfortunately, because that's very easy to do, but it also doesn't yield any reward. And eventually, one of your Linux sysadmins, one of your IT administrators, one of your technicians, your developers, is either going to go rogue, or is going to be laid up in the hospital, or is going to be terminated, or is going to have his or her laptop stolen. It's going to happen eventually, right? And if you do nothing here, you're going to have a problem. You could implement this with an existing tool. The MLA tool I've just described to you, which we'll be demoing here in a minute, is just an example. No reason you have to use that. You can go in there and write your own. It's very doable, just a couple months of development time, one skilled developer on the side. Not a huge challenge, it's doable. You can go with an existing tool. Cost of that is also reasonably low. You just need a few labor hours to maybe adjust the product to your organization, support it on an ongoing basis, make sure to answer users who have questions or concerns about it, right? Benefit is moderate on that. You get a decent amount of benefit out of it, right? You get to make sure that your sysadmins get to retain They're free and open source client devices. And you also get to make sure you're in compliance with policy. It's a win-win, provided that the policies are actually decent, but that's neither here nor there, right? Okay. Another option is you can create a new tool. As I mentioned, you can write your own tool from the ground up in your own organization if you want. You can go look at the examples I've done, check them out and say, hey, this guy's a terrible programmer, he's awful. I mean, I wouldn't trust this guy to tie his shoelaces, let alone write an encryption management system. Let's go out and write our own. That's fine. You can do that. The advantage there, right, you're going to get a tool that's custom tailored to your organization. It's going to come at a fairly high cost, particularly if you want to do a professionally developed product and dedicate full-time employees to it and labor hour, a whole 9 yards. It can get very costly, but it's also going to be a good benefit to your organization. It's going to be custom tailored to your needs, right? It's going to do what you want it to do. There's also the added advantage of not having to ask anybody else if you ever need support or help with it. Hopefully you'll have your developers right there in the organization, provided that you followed some lifecycle management like we discussed in the previous presentation. Right? Future directions with MLA. We could possibly do some improved server authentication, right? At the moment, MLA's authentication to the server is fairly rudimentary, both to the MLA server itself and to Active Directory. Standard LDAP and HTTP. I would in particular like to implement a REST API for the MLA server portion, right? Also implement client configuration. Right now, all of the tools are in the server and the client script to make this happen, but that client configuration, particularly on Linux, gets very distribution specific, right? So I think kind of what you were touching on earlier is how in the world do we address this client configuration in a platform neutral way? The client configuration component, all the communication pieces are there, but the logic actually needs to be fleshed out to make this happen on a distribution. At the moment, the configuration portion works only on Red Hat, SUSE, and Debian, right? Because I'm only one developer. But all the communication is there to implement what you need on other systems as well, right? We need to support more operating systems. There's absolutely no reason in the world, as I mentioned, that we couldn't actually take this tool and use it on Windows. Windows has PowerShell in most of the business versions now. PowerShell is definitely not Bash, but you get a lot of comparable functionality out of it. Uploading keys to Active Directory is substantially easier for Windows for obvious reasons, right? It's very possible you could actually port this tool to Windows and have all of your clients manage their encryption managed under one roof. Throw this out there. I am not a developer or a programmer by trade, especially and particularly not a web developer, right? And this will become very evident in a few minutes. You will see this very clearly. So the web face is full HTML5, validated, themed in CSS, right? So I would eventually like to also get some more themes on here that maybe look a little bit more professional. But be that as it may. Oh, and finally, the build process. Those of you who raised your hands and said you've dealt with Erlang before, have any of you ever messed with OTP, the build procedures and the system development and integration process? The Erlang, particularly for the server components, the Erlang build and distribution process dates back to, if memory serves, the early 80s. So it's kind of a relic and a dinosaur, and I would really like to get away from it and get to more modern distribution methods like actual GNU make files and so forth. All right, power is yours. Now, if you folks will give me a moment here to get some setup and a little bit of preparation done, hopefully we can go ahead and do the live demo here, and then we'll conclude the presentation there. And while I'm setting up, if y'all want to throw questions at me, please feel welcome to. Though it may take me a moment to answer here. So anybody have any questions on what you've seen so far? Any hands going up there? Nope. All right. What was my last time you held up there? 10 minutes? Yeah, Carla?
So is there something existing for Android devices like this, or could it be ported to Android?
Android, from my understanding, actually uses Lux and dencrypt under the hood to do its full volume encryption. There's absolutely no reason whatsoever this could not be ported, at least the client portion, to an Android application. It would be a challenge and it would be work, but it's definitely doable. There's nothing precluding it. And what I'm doing at the moment is I'm actually firing up the MLA server component of this on a remote system. Okay, server component appears to be up. Let me actually verify on my local side that it's working here, and then I'll show you guys what that looks like. Where am I on time here? We got 5. Yep, just enough time to finish this up here. Desktop. Interface. All right. So let's get this up here. All right, this is what the server component looks like. It's actually not running on this local machine. It's live on a machine elsewhere on VCU's network, right? A few of you may notice up there that HTTPS is not enabled at the moment. That's because I'm carrying around self-signed CAs with me and trying to adjust them for live demos. It tends to cause a live demo failure, right? And as I mentioned, please don't be too harsh on the styling and whatnot there. Right? You're going to get to a very simple interface for the MLA server component. Homepage with a brief landing, a little bit of info. List of computers. Obviously, there is none in the database as we just initialized the server for the first time. And a user and group management portal. Right? So far, so good. Nothing in there terribly complicated. There's a new user function, password changes, and there are 3 groups. Admins are folks who can do anything on the server, adding, removing computers, adding, removing volumes, the whole 9 yards. Key recovery are people who can actually go in there and view the encryption keys themselves. And the regular users category are folks who can just go in, see which machines are reporting and the reporting status, but can't otherwise view the encryption material. So it has a tiered approach very similar to what Active Directory uses for its key management. All right? And as we mentioned, there are no computers in there at the moment since we just initialized the server. Oh, there we go. All right. So, anybody have any questions about the web interface before we move on and actually run the client script and get these keys into Active Directory in the web interface? Right? Okay. So let's actually move on. And this is where I really have to keep my fingers crossed and hope that nothing explodes. We get a font on there that's a little bit legible for you guys.